Okay, welcome back to the Algebra 2 final exam review. In this video, we're going to cover section 16, in which we perform function operations. So just to recap what our function operations are real quick, and this works for any letters and any variables, so it doesn't really matter. The most common ones being f and g for our functions and x as our variable. So we can add functions together, and their notation for that is f plus g of x. And what this means is that whatever our functions are, we take f of x and we add it with g of x. And so when we're doing our examples, it'll be more clear how we do that. But just know that when you see a plus here, you just add your two functions. Similarly, if you see f minus g of x, this means that we subtract our two functions. We have f of x, and we're going to subtract g of x from it. So a minus here means we do subtraction. The next function operation we have is multiplication. So if we have f dot g of x, remember dots in algebra they mean that we multiply. And so if we have f dot g, that means we have f of g times g of x. Sorry, f of x times g of x. We can also do division. So we have f over g of x, and this is going to be defined as f of x over g of x. And our last one is a little bit different. It is called composition of functions. And so we say that f composed with g of x, this is given as f of g of x. So I commonly call this fog just because it looks like a little O. It's really an open circle. And it just stands for the operation to compose, just like the other operations. I kind of think of it as a small o for like f of g of x, because it's read that way when we're actually carrying out the operation f of g of x. So however you like to look at it, I think it makes funny words sometimes. We get fog, goff, hog, a bunch of other little words like that. I think that's fun. But that is our composition of functions. And when we do examples for, let's see, 237 and 238, we'll see that in action. But for now, I recommend writing down these function operations and having them handy. You will be provided them on your test day for your final exam. But I'm not going to elaborate on them any more than this. So that's kind of all the information you're given. Anyways, let's get started with number 229. So for number 229, we're going to find h of t. We have 2t minus 1, and we're given that g of t is equal to 2t minus 2. And now we want to find h plus g of t. So to do that, recall that this is just going to be h of t plus g of t. And we know what those are. We have h of t is given by 2t minus 1, and we have that g of t is given by 2t minus 2. So, to stay organized, I recommend replacing h of t, putting in parentheses, 2t minus 1, close parentheses, plus 2t minus 2, in parentheses. So h of t was this, and g of t was that. And now, if you recall from one of our earlier videos in this review series, that when we're adding polynomials, if we have a polynomial plus a polynomial, we can just drop the parentheses. This is just 2t minus 1 plus 2t minus 2. And when we combine all of our stuff together, we have 2t plus 2t, which gives us 4t, and the negative 1 minus 2, which gives us minus 3. And so this is our final answer, 4t minus 3. Similarly, for the next one, we have new functions. For number 230, we have g of x is equal to negative 2x squared plus 4x, and f of x is equal to 3x minus 1. And we want to find g plus f of x. And so, just like last time, this just means we have g of x plus f of x. And our functions are already defined for us. We have g of x up here, we have f of x up here, and so we're just going to replace g of x and f of x respectively. And what we get is negative 2x squared plus 4x, so g of x up here, plus whatever f of x is, which is 3x minus 1. And again, when we're adding polynomials together, we can just drop the parentheses. We have negative 2x squared plus 4x plus 3x minus 1. And combining all of our like terms together, we have negative 2x squared plus 7x minus 1. And this is our final answer. For the next one, we're going to do subtraction. So for 231, we have that g of n is equal to 2n cubed minus 4n squared. And we have that h of n is equal to 3n minus 2. And we want to find g minus h of n. So to do this, this is just defined as g of n minus h of n. So we replace g of n with whatever that's defined as, which in this case is 2n cubed minus 4n squared. And then we subtract h of n, which is 3n minus 2, so minus 3n minus 2. And remember, when we're subtracting polynomials, we can keep the signs the same on the first one, but we have to flip the signs for the second one. So this becomes 2n cubed minus 4n squared, but minus 3n plus 2. And so then we want to combine like terms, but we can't do that. We have an n cubed, an n squared, n, and a constant. This can't be combined any further, and so this is our final answer. For the next one, we have 232. This one, we have f of x is equal to negative 3x minus 4, and we have g of x is equal to x cubed minus 3 plus 2x. So we want to find f minus g of x. And remember, that's defined as f of x minus g of x. First, we state what f of x is. So f of x is negative 3x minus 4. So we'll put that in parentheses. And then we're going to subtract g of x, which is this x cubed minus 3 plus 2x. Keep the signs on the first polynomial. We have negative 3x minus 4. But because we're subtracting, we have to flip the signs on the second one. So this becomes negative x cubed plus 3 minus 2x. And now we just want to combine like terms. And we can even write this in standard form as well. That would be good for us to do. So we have an x cubed term. So we'll write that one first. Minus x cubed. I'll cross it off. And then we don't have any x squared terms, so we'll go on to x. We have negative 3x minus 2x. And that's just going to be minus 5x. Cross those out. And then we have negative 4 plus 3. And that's going to be minus 1. So we've combined all of our like terms, and there's nothing else for it to do with that. So this is our final answer. All right. Now we move on to multiplication. There we go. Better lighting. For number 233, we have that g of a is equal to a squared minus a. We have f of a is equal to 3a plus 1. So we want to find g times f of a. So to do that, remember this is equal to g of a times f of a. Well, g of a is a squared minus a. So we have a squared minus a. And then we want to multiply that with f of a, which is 3a plus 1. We don't need the dot in between. We can write it, but it's not necessary. So we have a squared minus a times 3a plus 1. And I guess over here, I'll make a box. And we're just going to multiply those out. We have a squared minus a, and we have 3a plus 1. So 3a times a squared is 3a cubed. 3a times negative a is negative 3a squared. A squared times 1 is a squared, and 1 times negative a is negative a. We want to combine all of our like terms. Well, we only have one a cubed term, so that's going to be 3a cubed. And we have negative 3a squared plus a squared, so that's going to be minus 2a squared. And now we just have this minus a, so minus a. And since everything is already simplified, this is our final answer. Let's look at number 234. For number 234, we have g of a times, I'll write out g of a. G of a is 4a plus 2, and h of a is negative 4a plus 1. And we want to find g times h of a. So this is defined as g of a times h of a. And g of a is 4a plus 2. So 4a plus 2. And we want to multiply that with h of a, which is negative 4a plus 1. We can make a box, multiply those out. We have 4a plus 2 and negative 4a plus 1. Multiplying that out, we have negative 4a times 4a, which is negative 16a squared. We have negative 4a times 2, which is negative 8a. 4a times 1, which is 4a. And 1 times 2, which is 2. Combining all of our like terms, we have negative 16a squared. You have negative 8a plus 4a, so this is going to be minus 4a. And then we have a 2, so plus 2. This is already in standard form, and we can't combine any like terms, so this is complete. The next one we have is number 235. Number 235, we have h of n is equal to negative 2n plus 2, and we have g of n is equal to 2n. So we want to find h over g of n. So to find that, remember this is just equal to h of n divided by g over n. And so we just put one function over the other. We have negative 2n plus 2. So that's our h of n, divided by 2n. And so if you have this as your final answer, I'll take it. But as we saw in lab the last week and a half when we were simplifying rational expressions, we could simplify this a little bit. We could factor out a 2 from here, from the numerator. And if we do that, we have 2 times negative n plus 1 divided by 2n. And if we cancel out the 2's, this will be negative n plus 1 divided by n. So either one of these answers works. However, I would prefer you have this one here, where it's simplified. All right, let's look at number 236. Number 236, we have h of t is equal to 3t minus 1, and we have g of t is equal to negative t squared minus 2. We want to find h over g of t, and we just have to recall that that is equal to h of t over g of t. So we put one function over the other. We have h of t, which is 3t minus 1, over g of t, which is negative t squared minus 2. This can't be simplified anymore, and so this is actually our final answer. There's nothing else we can do with this. For 237, now we're moving on to composition of functions. So we have g of n is equal to 2n plus 1. We have f of n is equal to n squared plus n. And we want to find g composed with f of n. So this means g of f of n. And so this one's a little bit trickier. Is basically what we want to do is, let me use a different colored pen here. We want to take all of g of n, or sorry, all of f of n and input it into g of n. So if I write g of f of n is n squared plus n. And so when we evaluate g of n squared plus n, that means that this n right here in g, we're going to replace with all of this. So we're going to have 2 times n squared plus n plus 1, but instead of an n right here, it all gets replaced with that. So we have n squared plus n. And now we have to simplify this. This is 2n squared plus 2n plus 1. And this can't be simplified any further. So this is our final answer. For number 238, we have g of n is equal to negative 3n plus 5. And we have h of n is equal to n squared plus 4n. Now we want to find g composed with h of n. So this is just g of h of n, which means that we have g of whatever h of n is, which is n squared plus 4n. And now, wherever we see an n in g, so we only have 1 right here next to the negative 3, we're going to replace that n with n squared plus 4n. And so what we get is negative 3 times all of that plus 5. So we see that we still have like this 3n plus 5, but now instead of writing n, we have n squared plus 4n. And when we simplify this, we have negative 3n squared minus 12n. We just multiply negative 3 times this, negative 3 times that, using our distributive property. And then we have plus 5. And so this is our final answer. So the last two on this section, it's actually called, this is not something that's covered on your exam, but I think it's a common enough question that you may see, and I think it's worth talking about. So this is called a linear combination, but basically we have for, number 239, we have g of n is equal to n squared plus 2. We have h of n is equal to negative n minus 5. And we want to find 3g plus 4h of n. So what this means is that we're going to take 3 times g of n, and we're going to add it with 4 times h of n. And so it's not that different from the first two questions we had on this video, where we're just adding g of n and h of n, but we're also just going to multiply g of n times 3, and we're going to multiply h of n by 4. And when we do that, g of n was n squared plus 2, so we have 3 times n squared plus 2, plus 4 times h of n, which is negative n minus 5. We just want to multiply this together. We have 3n squared plus 6, not a minus. And then we have 4 times negative n. Okay, so it was a minus, never mind. Minus 4n, and then 4 times negative 5 is negative 20. And now we just have to combine like terms. We have a 3n squared right here. We don't have, well, we do have one linear term here, so minus 4n. And then we have 6 minus 20, which is minus 14. And this is our final answer. So, not too bad. It looks a little different from the first 5 operations we had, but it's just taking basically the addition one a little bit further. Let's try number 240. So 240, we have h of n is equal to 4n minus 3, and we have g of n is equal to n cubed minus 2n. We want to find 5h plus 5g of n. So this just means we take 5 h of n's, we add that with 5 g of n's. So if we know what h of n and g of n are, we just plug these in and simplify our expression. So we have 5 times h of n. H of n is 4n minus 3. Plus 5 times g of n, which is n cubed minus 2n. So we're going to multiply 5, we're going to distribute 5 with 4n minus 3. That's going to give us 20n minus 15. And we're going to distribute 5 with n cubed minus 2n. So plus 5n cubed minus 10n. We combine all of our like terms. We do have 1n cubed here, so it's 5n cubed. But we don't have any n squareds, so we skip that one. And now we look for our n's. We have 20n minus 10n, which is 10n. And then we have our constant, minus 15. And this is our final answer. And so that concludes our video on function operations. So thank you for watching.